Hi, welcome to April's show for IoT North. Sadly, John can't join us today. He's stuck on some boat somewhere with no Wi-Fi or some excuse like that. But hope John's having a good time whilst he's away. I do apologise if there's been any confusion with the listing of this month's show. That may have happened because I was in the US and trying to do it, and it was sticking it on the time zone for it, yeah. But in any case, you'll be able to catch up on the website, iotnorth.uk. So thanks for joining us. We are joined by Sander van der Velde from Holland. Hi, Sander, how are you?
Hello, Paul. Hello. Welcome. It's going great.
Thanks very much for joining us today. Really looking forward to your talk. Do you want to give us a little bit of an introduction to yourself?
Yes. Well, my name is Sander van der Velde. Sander is short for Alexander. And I'm a IoT solution architect for Alten, Netherlands. And Alten is an international company for consultancy and engineering. And our target is the high-tech markets. And well, I'm doing the IoT for Azure. And next to that, I'm also an MVP, a Microsoft MVP. That doesn't mean that I'm a Microsoft employee. I'm just an enthusiast, and I'm willing to share all the knowledge that I have, and the experience and the fun with the tooling for Microsoft.
That's excellent. Where can everybody find you? Can they find you on Twitter?
Yes, I'm available on Twitter. My Twitter handle is in the name tag. It's @SVELD. But you can, well, if you Google my name, I think I'm all over the place.
That's great. So how long have you been doing these types of shows and evangelizing?
Well, I always liked to share knowledge and to speak about my passion, programming. I did it all my life, I think. But somewhere in 2017, Microsoft started with IoT. And for me, that was something, hey, that's interesting. That reminds me to the stuff that I did during college. So from being a web developer and system developer, I moved over to IoT. And well, if you get in contact with Microsoft, you get some information and they learn to know you doing presentations like this or workshops and even working together with Microsoft. At some point, they awarded me with the MVP award for that.
Excellent. What was your first IoT project?
Whoa. Well, I know I started with Arduino. Of course,
Yeah.
I think everybody starts with Arduino. Just because it was available. I got one from a friend. He said, let's play with this. And from there, I discovered that devices like even an Arduino can be connected to the cloud. And well, from there, nowadays I'm doing a lot of edge development. So industrial PCs, industrial computers, running in a factory and have them connected to the cloud in a secure manner. And of course, running logic on the edge device, even when there's no internet connection.
So, are you using Azure for that?
Yes, I'm mostly using Microsoft Azure for that. That's the main tool that I have. There are other clouds, and of course, but I wanted to specialize, and well, I've always been a Microsoft software developer. So for me, it was a natural choice to move over to the Microsoft cloud.
Excellent. Hey, let's fire ahead with your show, and I'm going to step back. I'm going to share your screen, and there we go. So over to you.
Okay. Well, thank you for having me in the show, the IoT North show. And today we will look at connecting LoRaWan devices to Azure. Keep in mind, I'm not working for Microsoft. I don't have any stocks. And also, I'm not working for the Things at Work, but it's just one of those prominent LoRaWan networks. And well, I picked this one to do this show about it. So the agenda for today is, of course, a little introduction into what is LoRaWan. We will look at how the Things at Work supports offers LoRa connections. We will look into some different ways to connect devices to Azure. And well, there's even one more thing, of course. A presentation is not complete without the one more thing, of course. So let's get started. For those who are not familiar with Microsoft Azure, it's one of the major cloud offerings. And in the cloud, you can run resources. That can be a virtual machine. That can be a database. That can mean, well, I can list hundreds of services which are available in cloud solutions. But today we will look into the stack Microsoft offers regarding Azure IoT, the Internet of Things part. And as you can see, there are already a lot of services shown here. Each block is a different service. We will mainly look at the thing in the red rectangle. That's the devices connected to the Azure IoT Hub. And the Azure IoT Hub is a cloud gateway where devices are registered. They have each device has its own key. And the Azure IoT Hub offers the ingestion of all the telemetry coming from devices, and then the data is sent towards the cloud, the other cloud resources, in either a cold, a warm, or a hot path. And on top of that, you can put your own enterprise layer, your business management and business integration. As I said, we will focus on the left because in the standard offering, you connect a device directly to the Azure IoT Hub, either with a direct internet connected device or with an edge device in between. But how about third-party platforms? If you have a device connected to another platform, another cloud platform, how do you integrate it? Because this is also a solution that we see a lot. On the left, we see devices which are mostly capable of connecting directly to the internet. The ESP on top has this little Wi-Fi chip, and there's a Raspberry Pi where you can use a cable, or you could put a Wi-Fi dongle in it, or the modern ones already have Wi-Fi. But the stuff on the right, like the smart meter, the smart thermostat, or your UE lights, they are not directly connected to the internet. They are connected to some provider. And how do you get that information into the cloud? Well, there are a number of solutions. I put a few of them in the middle regarding how they connect. There's something called LoRa, and there's something called narrowband IoT. Those are communication forms of those devices. Because today we will talk about low-powered devices, like in an Arduino, and they are connected to the cloud. That's what we want. And why are these low-powered devices so interesting? Well, that's because of the promise. If you go for a little device, an Arduino with just a simple battery, then it's promised that they have a range up to kilometers, miles away. And the battery will work for years. And there's communication, maybe even up and down, although for these devices, there's normally a cap on the bandwidth. And we think that's okay. For these low power devices, simple task. So there's not much to do. And these devices are normally found in the green area in this table. We see the outlined LoRa communication, and the promise is that they have a reach until up to 20 kilometers, and the battery life is for 10 years. And there is some data that can be sent, 50 kilobytes per second. But if we look at the competitors like Narrowband IoT, again, 10 years and 10 kilometers. And another one is Signafox, also with 10 years of battery and 50 kilometers of range. This is a really interesting device. You can do a lot with that, I think. But keep in mind, there's something called the law of physics. The farther you want to communicate, the more power you need. So the battery life will drop drastically if you want to communicate over a long range. And that's why and also the farther you communicate, the bigger the chance is that the message will be corrupted while communicating. So then, well, it's not received, so you have to send it again and again and again, and each time you will eat up a little bit of that battery. So that's why small messages are in favor. So you have to choose. There's this law of physics that says you can only pick two of them. So it's either a long distance, lots of messages, or low power usage. So with that in mind, one of the solutions is LoRa communication. It's a protocol. It's open and available. You don't need a license to work with LoRa. These are in the open spectrums of the communication bands. But keep in mind, you still have to be aware of that regulation. You cannot send massive amounts of data over that communication band, because then you will, well, all the other ones who want to use that same band, they are not able to communicate anymore. How do you connect to LoRa? Where does it start? Well, first of all, you need devices with a little chip on it. That's called a node. And nodes are connected with a gateway. And that's some radio station, a gateway station somewhere in the neighborhood, say within 5 kilometers in a urban area. And these gateways are capable of connecting to a cloud solution, a portal with resources behind it to get all the messages in, and then you can attach your own application to that gateway or to that platform. So here's the same story again. We have the end nodes. It could be a smoke alarm or a trash container with a little sensor on it. And once in a while, it sends a message and it tries to connect to this gateway, which is somewhere in the neighborhood. And once a message is picked up, is it sent towards the the back end, the network server of the things that work, and then you can attach your own server applications. And keep in mind, the whole communication should be secured. It's your message that you send. It's your node. So you know what is sent, and you also want to be the only one who receives the message on the other side. The gateways, they are mostly public. That means that if you have a gateway, you probably will receive messages from somebody else. On the gateway, the message is not readable. We only get this byte array in some encrypted solution, and that's sent over to the cloud, and you alone are able to see your own messages. Well, how does that look like? Well, the things that work started as a community project. A couple of people bought a number of these gateways, and they set up a backend, and it's quite open source, so you can even start your own platform if you want to. But they provided this worldwide platform for handling messages. And the problem with any network, you need connectivity. And the idea with the things that work is, if you need a network, just become the network. Buy this 100-pound gateway. They are even cheaper if you are searching around on the internet, and suddenly your whole neighborhood is connected to the things that work. So that means that your whole community can make use of long-range communication, low-powered, and even uplink and downlink. So you can send data up to the cloud, and you can even send commands back. It's a community-driven provider. So to keep it a little bit in hand, you cannot send too much information. There's a potential, there's a chance that you will be throttled. I believe you have something like 30 seconds per day per device to send information to the cloud, which is more than enough for a couple of hundred of messages. But if you send messages every second, there's a chance that you are throttled. So keep in mind with that. Well, I looked up where the IoT North is located, the community, and I believe it's in Leeds. So I looked up this map of the world from the things that work.
We're all over the country. I'm in Newcastle. John's in Leeds. We have Manchester. Okay. We have Scotland. We have Solent, and we have 2 groups in London as well.
Okay. Well, I was in contact with your partner, so that's why
he's supposed to be in Leeds. I think he's still around Scotland somewhere at the moment.
And the beauty is that Leeds have quite some gateways. There are a lot of them, and there's even this war driving map, this heat map with communication instances. And I believe the redder it is, the more messages were received. People are driving around with a LoRa gateway and with a GPS tracker, so they know where they are, and they get a connection with some gateway in the neighborhood, so they know how to communicate and which gateway is active. So it seems promising. If you're living in the neighborhood of Leeds, well, there's a good chance that you can connect your devices. Because it's all around UK, go to these links and check out your own neighborhood. And if there's no gateway, just add one. Invest a little money and have a lot of fun, or with your community, your local community. So, well, this is how the things network works, or probably any LoRa network. But how about the actual sensors? And for that, I can switch over to a second camera. And there I have a couple of examples of sensors. And first of all, some, well, Arduino with a LoRa chip on top of it. And this is also an Arduino with a chip connected to it. You can build them yourself, but there are also commercial offers, like this parking sensor from Bosch. You just park your car on top of it, and it will change the change in the magnetic field, and it will say, hey, there's something put on top of me. And you can even drive with a wheel over it. It will not crack. And what about this one? A LoRa mousetrap. So once in a while it gives a pulse about how is the battery quality, and when a mouse is catched, it will also give some information. What else? There's this temperature sensor, and it even has the possibility to add a extra sensor next to it from Dragino. And last but not least, there's this beautiful little device, and it is used for sensing if somebody is sitting near a table, then it will sense the movement. Or you can use a magnet to sense if a door is opened or closed. And it can even sense when there's humidity, moisture in the neighborhood. So there are many sensors available. Last but not least, I also have this one. This is a gateway, and it's the Things indoor gateway. It just runs on power. Although, if I take this off, I can even get it connected over a USB-C connection. So I have a LoRa gateway, a portable LoRa gateway on USB-C, and if I attach it to my phone with Wi-Fi shared, I can get my information from LoRa devices anywhere I am. So with that, we've seen a number of sensors. Today we will look at the SenseCap sensors. I have a couple of them, and we will play with them. Because that's the first thing that we want to do. How do we connect a device to the Things portal? So let me move over to the Things. Where is the? Here it is. Too many screens. Okay. Well, this is the portal of the Things network. It's nothing more than a free account that I use. You can start one yourself if you want to. And first of all, let's go to the gateways, because there's a gateway running here in my house. That's this one. It's connected, as you can see, the micro tick. And the other one is the portable one, which is currently disconnected. So I should be able to see information of LoRa devices running through my gateway. At this moment, the neighborhood is a little bit quiet. There are not that much gateway nodes in here in the neighborhood. So let's add an application. I already entered one, a application, and let's add a device. There are no devices registered already, so I can add a device. Let's move over here. Well, there are two ways to add a device. You can go for a manual process, and you have to enter a lot of secrets about the device and a lot of settings, but there's an easier way. There are a lot of companies which are creating LoRaWan devices, and they got the chance to actually get them listed in this repository. In this case, I'm using a SenseCap. Oh, that's not the one. The SenseCap, and that's this temperature and humidity sensor that I have in my hand right now. And this is a temperature and humidity sensor, this one. And I say I'm in Europe. And from there, I have to fill in that I'm using the Europe spectrum. And then I have to fill in 3 keys. That's the up EUI, def EUI, and the up key. Well, luckily, I looked them up. There's a sticker or there's a website where you can get that information. Let me check out. There it is. First, the def EUI. Put in here. And there's the app EUI. I copy and paste it from a document. And then there's the up key. And give my device a sensible name. So temperature humidity 01. That's something that I understand. And the device is registered. But of course, I still have to put it on. So let's go to live data. And well, the SenseCap is actually a cap. There's a battery part. And on the camera, you can see it. There's a battery part with some electronics in there. And this is the actual sensor part of it. And there's a little switch. So I put it on. I push the button. Yeah. And I close it. This is something that I will do multiple times today. So you now have seen that there's a little switch in there, and there it is. There I have a first message coming in from the device. And there's not that much to see, although we can see that the message was received by this Mqtt gateway. It is possible to get the same message from multiple gateways. Then there's a list. So I registered this location with the Mqtt sensor gateway, which I just filled it in. There's no GPS in my gateway, but there are also gateways with a GPS in there. And then you could do some kind of triangulation. Let's take this message. Let's look what's in there. And it says, okay, the battery is still 100%. There's an interval of every 5 minutes. And there's a firmware information. And let's look at this one. And then we see that it is, maybe I'm looking for the actual temperature. There it is. There's the temperature and humidity, which is sent by the sensor. So I think it's something like 20 degrees and a humidity of 56%. And the message comes with these measurements IDs, 4097 and 4098. And I can look them up. Actually, here they are already. Air temperature and air humidity. So I have a sensor running, up and running within minutes. There's only one thing that you have to remember. This sensor is of course not sending a JSON message. And we see this message with beautiful JSON, but that's a little bit too much of overhead to get JSON over the air. It's probably nothing more than just a few bytes. Actually, this is the actual payload, base64 encoded, so it's even smaller than this, which is sent over by the device to the cloud. So how is this payload decoded into this JSON? Well, for that, and that's also something that LoRa platforms have in common, they have payload formatters. In this case, a uplink a formatter, and there's also a downlink formatter. So you go from JSON back to a byte array. But because we're using the device from the repository, I don't have to fill in my own formatter. I could overrule it. I can put in some custom Java formatter in there, but I don't have to because it's already there. An example of this, actually the formatter I believe that we're using right now at this moment, it's on GitHub. Since Seed Studio is just providing it, so you can alter it if you want to, and then work with that one. So you see that a byte array comes in, and from there, it's actually somewhere at the bottom that it will say, okay, return decoded. So decoded messages, blah, 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 blah. Here is the JSON message created. So that's why we see that information coming in. So demo number 1 was executed well. What we've seen is that I have these devices, and for each device I need the dev EUI, app EUI, and app key. SenseCap offers me a website for that. I fill in the secrets on the side of the sensor, and I get all the information that I need. There are also companies which already put all the information directly on a sticker on the box of the device. So if you buy one, don't throw away the box, because maybe you're throwing away all the secrets. And we were able to add the device to the LoRa platform. And this is really nice. Although there's one more thing that I forgot. The data is coming in, but how do we consume it? And for that, let's go back to the portal, because the data is now arriving inside the LoRaWan portal. How do I get my information out of it? Well, there are a number of integration available. You can integrate with the Mqtt protocol. You can, of course, do something with the Azure IoT Hub, or we can use webhooks. Well, a webhook is nothing more than a endpoint, a HTTP endpoint somewhere in the world. The Things that Work already provides a number of webhooks, so maybe you see some platform that you recognize. I use the custom webhook, and all I have to do is put in a name, and I say I want to have the answer in JSON, and here is a free webhook website. So I take this one, I fill in the URL. Keep in mind that it's with some key, but you can also work with an API key and even add basic authentication if you want to. I'm interested in the uplink messages, so I add the webhook. The webhook is connected, and what I do, I restart the device. I close it, and at some point, if I go to here, live data, we will see that it is actually starting to communicate again. And that's a pity. Maybe I was waiting too long. I think I know the problem. I have to go for this one. I took the wrong. This is the actual endpoint that I need to use. Here it is. Here we have a message coming in. So this is how the messages are sent to some service in the cloud. Keep in mind that you get the message only once, and here you see the temperature and humidity, so it's up and running. So now you can do whatever you want with the messages coming in. But of course, I'm doing something with Microsoft a lot. So how about working with Microsoft tooling? And the first demo that I do is with Azure IoT Central. In the previous picture, we've seen a lot of Azure resources, the IoT Hub and all the stuff behind it. Well, Microsoft figured out already that that can be a lot of hassle for somebody who's willing to just start or to try out how Azure, how IoT is doing. So they come up with this Azure IoT Central, which is a application platform as a service, or also called a SaaS platform, software as a service platform. But it's more than that. It's you have to figure out how things are working. So it's more of an application. By the way, on the April 7th, there's a free summit. So if you are interested and if you like the demonstration that I give about Azure IoT Central, join that summit. So so Microsoft has this IoT Central, but the problem with that we face is that just with the thing that we had in with the IoT Hub, it does not recognize directly another solution, another platform. So we have to put something in between, and that is so-called a bridge. What we're going to do in a moment is creating a webhook in Azure, and the data that is coming in is sent towards the IoT Central solution. So let's first look at Azure IoT Central. Here it is. If you want to, you can create your own account and try playing with Azure IoT Central, because there's even a free plan that you can attach 5 devices for 7 days. And there are also other plans where there are always 2 free devices to be connected. And depending on the amount of message that you send, there's another pricing point for that. But the first 2 devices are always free. Well, what I did already was creating a application. That's this one. And if we go to the device group, then there are no devices registered at this moment. That's of course because it's still empty. But what we need is something in between. And that's a bridge. And luckily, there's already some documentation about that to create a bridge between the things that work and Azure IT Central. And that's this bridge. There's lots of documentation about it. So what we do is we can push this button, deploy to Azure, and it will ask me for some credentials, of course. And there I have to fill in a number of things. Let's wait on that. Okay, it's taken a little bit more time than expected. So what it will create in the end, because I created already in advance, it will create this Azure function. And Azure function is an Azure resource which acts like a HTTP endpoint, like a webhook. And for some reason, it's a little bit slow. Yeah, it's still okay. This one is a little bit faster, luckily. So let's go to the endpoint, the Azure function. Here it is. And this is all generated by some script that we wanted to do with the with this one. This is actually the script that we can use, and it will create in the end all the resources that we need. Actually, the webhook. And what we need is a scope ID and some key. Those are secrets from Azure IoT Central. If I go to the application, actually I go to permissions, and there we go to API tokens. No, device connection group, there's the one that I need. Then we get the scope ID, and we get one of these tokens. Those have to be filled in. And then if we review and create it and we wait for 5 minutes, we will get all the resources behind as seen here. And what it creates is this Node.js application. And that picks up a message from the world. In this case, the things that work solution application will send the images, the messages to this JavaScript Node.js application. And there I put in this little piece of code. It's well documented, where I have to know the device name and the decoded message. That's what I need, because I want to know from a certain device is sending a certain message. So that's what has to be added. Why is it done like this? Because the same webhook can also be used by Sigfox or for the particle cloud, or actually any other cloud. This is the only thing that is the things that work specific. So we have this website up and running. Let me check for sure. If it's up and running. Yes, it's running. And in the webhooks part, I add an extra webhook, this custom webhook, and it's called IoT Central. I fill in JSON, I fill in the URL of my Azure function, the HTTP triggered Azure function. I'm interested in the upload messages, and now it is connected. So if I go back to my Azure function, that's a pity, I closed the screen already. Then we can see in the logging that it's actually It's actually running. Because the Azure portal supports me with some tooling. Here it is connected, and well, the device, I reset it again. I close the device, and let's go to the live messages. I think I didn't do it correctly. Yeah, there it is. Again, we see the that it's trying to join again. There's just a reset button on here, so I can start all over again. And here we see that actually we have an IoT integration running now, and it's trying to register the device, and it's sending the telemetry from the TH01. So that's good news. So let's go back to my list of devices. And there it is. We have a device. It's proficient, and if I look into the data that's coming in, the raw data, then we will actually see some information coming in. I'm not sure. Yeah, there it is. We have the battery and the upload information. So that's working as expected. Now, this is of course raw data. Azure IoT Central offers us a way to work with dashboards. We can explore the data which is coming in. We can even execute rules if data is coming in, and well, we can get alerts. And there's even an export solution to send the data which is coming in to other resources, for example, Azure resources. So this is just a glimpse of what Azure IoT Central can do. But for us, it was a nice way to see how to work with the things that work and another solution with a bridge in between. So what we had to do is deploy that bridge. We had to make that little change. If you run this for the very first time, don't forget to execute npm install, because it's a Node.js application. It hasn't run yet, so you have to do that by hand. And once the data comes into the bridge, it's then mapped to a device inside the Azure IoT Central portal. In this case, we have a light sensor, and there's a certain amount of light measured. Well, there's one more thing that I want to show. Next to exporting it as a webhook, we can also work with Mqtt. And why is that interesting? If we look to the portal, we can also work with integration based on Mqtt. And for those who are familiar with Mqtt, it's a transport protocol to broadcast messages to listeners. And it's a two-way communication. So it's supported to not even not only send data towards listeners, towards clients, but also receive messages back. And to demonstrate that, I have this Visual Studio application, console application. And if I look that it's written in C#. I have the name of my application, I have the name of my device, and I'm able to read all the uplink messages from that device. That's shown here in this subscription. You can also listen for all messages from all devices. Then you need something like this. So it's only the application and the hash sign tag, hashtag, and then you are able to receive messages from all devices. Keep in mind, as I said already, it's also possible to send a message towards the cloud, towards the portal, towards the device, and that's done with something like this. For a certain application, for a certain device, I do a push and I send some byte array. And well, from this device, I was not quite sure what to send, but you can look up the manual and then there's information about the byte array that you can send towards the device. So that goes beyond the formatter. You actually upload a byte array directly to the device. But I'm not going to execute it today because maybe I will break the device. It will go in some error state and it will never recover. But what we can do, of course, that's why it's grayed out. I can actually start listening to device messages. So let's start the application. And keep in mind, this is a console application. So it is stateful. There it is. And if I, again, open the device, reset it, and then let's wait. There it is. We get the information about the from this device. Let's see if there's something familiar. Well, we see the gateway, and we see some payload stuff in here, still with the initial hardware and software version. So maybe in one of the next messages we will see the actual temperature and humidity, and the battery usage, etc., etc. So this is how simple it can be. There's only one thing with an executable. Well, executables need to run on a CPU. So if you want to deploy this in the cloud, well, you have to either run it on a virtual machine, or, and that's another way, you can use a web job. Microsoft supports web jobs in Azure. It's part of the application services, so it will also run next to a Azure function, and a web job can be an executable. So that's a nice trick. There's a link below where that's explained how to do that. So we have seen how the Things Network works with devices. We have seen how the data can be sent in a number of ways to other cloud platforms, either with a webhook or Mqtt or with the bridge solution. But how about direct integration with Azure IoT Hub? Shouldn't that be nice? And this is something that, well, I go back with Things That Works back in 2016, I believe, already. And we have talked about this a lot. And somewhere a year ago, I got a message that they were actually working on the integration. So I'm really fun to see how this has grown into a full integration between the Things That Work and Azure. Because what they do is a really nice offering. it's possible to have devices registered in the Things network or in Azure, and these are kept in sync. It supports uplink and it supports downlink. Well, then we are actually good to go. And especially the device registration in the IoT Hub is a really nice thing, because from a developer perspective, from a Azure developer perspective, I'm not familiar with the cloud platforms which live out in the outside world. So probably a developer is not aware about what does the LoRa platform looks like from the Things network, and if I want to have a device registered, then I have to learn the interface of that platform. Here we have a nice solution where we actually stay within the Azure portal and within Azure, and we can still work with LoRa devices. So again, let's see how this works. If we go again to the portal, let me close this one just to know for sure that I'm not consuming that much compute power on my tablet. If we go to the integration, then you can see there's something called the Azure IoT Hub. And there we see that the Azure IoT Hub integration works with a number of credentials and an IoT Hub which is created somewhere in the world. And to get this working, we first need an IoT Hub in the cloud. You can do this by hand. You can create everything in Azure and then fill in the stuff that is in here. But there's a more elegant way. As we've seen already with the bridge for Azure IoT Central, there's this way to work with deployments. And again, I fill in my credentials. I go to the Azure portal and I get this wizard. If it starts, and what I need at least is this application ID, the cluster address. We are working with a application in Europe, and there's an API key. And I already generated one, so I'm not touching this, just to make sure that I'm not ruining my... there it is. Come on. Okay. Well, all we have to do is to, and this will create a new IoT Hub, a one that's not there already. So I have to fill in the stack application ID, the API key, and keep in mind you have to overwrite this one. It seems like it's already filled in. It looks like the one that we've seen here. Oh, wait a minute. We've seen here, but keep in mind there's still this EU1, so it's not correct. I burned my fingers a number of times by forgetting to change this. Well, if I go for review and create, I get actually a complete solution generated. But I did it already up front. So let's go to my portal. It's a little bit slow today, but it's everything is slow, and I think I have too many pages open. next to the broadcast that's also running. So let's go to resource groups, and there is this North IoT Hub integration. For those who are familiar with Azure, you will see the IoT Hub, which is created. Let me close this one. We see an IoT Hub. There's an Azure function in there. There's an event hub for sending messages over in there, but the main part is this IoT Hub. And as you can see, this is the IoT Hub. We are allowed to send 400,000 messages a day, and it was already attached. So if we look at the devices which are registered, we will see that there is a TH01 already, which is on par with the sensor that we registered a few minutes ago. So let's add a new device in the Azure cloud. And I call it Light01. Save it. Here it is. And normally a device is connected to Azure using the special credentials, for example, this symmetric key that is used, but it's also possible to connect with a certificate. But we skip that because this is just a registration of a device that will not be used actually. We use the Azure function, and which is also next to this one, and the Things network portal to actually connect to our physical devices. For that, we have this demonstration of this device twin. It's just a document which describes the context of our device. And in there, we can put so-called desired properties. And the desired property is normally a message which is sent to a device when it connects. And let me look up what we have to fill in. That is this part. Oh, it's not true. There is desired properties, but what we have to fill in is the tags. And here it is. Let me share this a little bit so we see what's happening. In the text, I can describe the context of a device. In this case, I'm describing that this particular device, the Light01, has a number of keys. As you can see, the app key, the join EOI, the dev key, and it is from a certain type. It's a SenseCap device. This is actually all the information that I normally fill in with the repository wizard, which we have seen a few minutes ago. So when I save this and I go to the Things network, here it is. Here is my Light01 device. So these two are on par. If I deleted TH01, the temperature humidity sensor, it will also be deleted over here. So these are actually kept in sync. Well, the sensor itself looks like this. I have it on camera. You can even change the angle for measuring the temperature, the light. So again, I open it, and now you see the how smart they made this, because this is quite generic. It's a LoRa sensor with a big battery in there. Let me And this part is the sensor part. So I reset it. And here we see that it's actually trying to join. And I have this little tool available. Let me check out. This is the Explorer for incoming messages. And here we have the light 01. And we can look when if there's telemetry arriving. So let's start this. And let's hope that we are on time. Let's go back. Well, you see that there's some information sent, and here it is. Here is the information coming in. Let me change the screen a little bit. We see actually telemetry arriving in the IoT Hub for this particular device. So we have a connection live from the Things at Work to the IoT Hub. And to prove that it's actually arriving, we can also look at the Think network of where was it? This is the one. We can look at the device itself, because messages sent from the Things at Work are sent in two ways. It's either the as an event, which we've seen in that IoT Explorer. These are events, the JSON messages which are coming in and which can be picked up by other Azure resources. But the same information, at least the last incoming message, is sent in saved in the device twin. So if I look at the device twin in the reported, we see that there's a certain amount of light for 4099. So let's look in here. 4099 light intensity. So the information is available for us either as a message, and we get it as a reported property. The device reports a certain value. Well, if we go to the and this is of course upload, but as I said, it should also be possible to send data towards the device. Yeah, that's available. If I go to the deployment guide and I go a little bit further on in the guide, then it will say, wait a minute, here it is, the device twin, that we get the reported properties, the reported data from the device, but we can also send messages towards the device. For example, we can send a decoded payload, and keep in mind, this is a JSON message. And we can say, okay, let's put it in the decide property. So I desire that this device makes use of a message, a so-called downlink message, where I say the color has to be red. Of course, this has nothing to do with the actual light sensor. This light sensor will probably ignore it, but it's just for demonstration that I can send something towards the Things Network portal. If I push save, and I go to the live data. Here it is, encoding downlink data, and it has an exception in here, as you can see. There's no encoder defined for the incoming message. Why is that? Because there is no downlink formatter at this moment. It's not added. I can create one myself. I can write one, but I was not able to add this in this demonstration, but it is capable. Or better, contact your supplier, the manufacturer of your device, and let them build a beautiful formatter. Why not? They can add it to the repository, and you get it for free within seconds. So we have seen a full integration with Azure IoT. We have seen the deploy button where we can fill in the information, and the Azure IoT Hub is connected to an extra Azure function, and together they provide this whole integration. And so that means that the things that work can send messages towards the IoT Hub. And if something happens with the IoT Hub, a device is created or a device is deleted, that information, and even a downlink message, which we've seen here, the color which was sent, it's picked up by the Azure function and it's submitted back to the things stack. So, well, we have a full integration. Keep in mind that if you want to make use of that full integration, you have to change that device twin. I added the tags. Here I did it in the portal. This was done by hand. This is not really well if you have to register thousands of devices. But luckily, everything I did in the portal is also programmable. You can do that with an SDK, or you can even do that with plain HTTP calls if you are brave enough. We have seen the uplink message support, and we have seen the downlink message support. So, full integration. And now for one more thing, which I mentioned at the beginning of this presentation. The Azure portal can also be used to host your own private the Things Network stack. So the whole backend of the Things Network is made open source, and it's available for you to run in your own portal. So you can register your own gateways, and you can register your own devices to your own portal and have your own integration. So you're not depending anymore to any other cloud, LoRa cloud provider. You are your own LoRa cloud provider. Of course, you're still limited to the amount of message you can send on the open frequency bands, but you're in full control. Well, there are a lot of links and stuff that I've shown today. These slides will made available for you. Of course, you can see all the addresses already here in the screen capture. So a big thank you for joining my presentation, and I hope you enjoyed it. Well, Paul, I think it's time for some Q&A. I cannot hear you. I cannot hear you,
Yeah, it
Oh,
helps if I turn mute off. I still haven't learned from 2 years of using Teams. Dick has here, what do you see as the next major development in the system?
the system. That could either be the things that work or Azure. Well, first of all, this is already a big step because now we are able to integrate within minutes 2 different worlds, and you can build your own IoT platform on third-party platforms like this. So I encourage to have other platforms the same ease of configuration. I've worked with a number of other LoRa platforms and third-party platforms, and this is by far the most solid integration, two-way integration. So if you figure out a little bit how this is working, because all the stuff is on GitHub, you can build something yourself. So you can, if you have your own third-party solution, well, you can check out how this is done with the things that work, and you can build your own solution.
Very cool. Michael says, very, very good presentation. Thank you. Sander, thank you very much for that. Really appreciate it. I do apologize. I have something I need to jump to in 3 minutes. But really appreciate your support and input here. Really, really good, as Michael said. Just to give everybody an update, that May's IoT North will be the first Tuesday of May. And that will be John George Val's understand the IoT landscape around IoT and IoT security as well. So it's something that we haven't had very often, but we're going to have a bit of a security conversation in our May chat. Thanks very much for joining. And I'm just stalling now to find the outro. Totally disorganized as always, but thanks very much for the support, and please do keep following. The show is always available on YouTube and on our website, iotnorth.uk /events. Thanks very much and good night.